Thanks everyone again.
Yes, sir.
Yeah.
Very good evening or good morning to all of you. Uh, I would first of all thank Professor Krishna Reddy for the kind words and also have supported me quite a lot, he and Professor Krishnanand, for on many aspects of my career. So thanks to you, sir. I have chosen the topic for today's webinar is mercury polluted soils from waste storage yard, uh, modeling and remediation. This was a simple mistake for an industry. We'll see a case study and how it has created such a problem that and how we have remediated. So it's a practical problem what I'm going to talk about in this particular uh, webinar. Uh, so in fact, if you look at it, the history side in 2003, UNEP declared mercury as a pollutant of greatest global concern due to its persistence in the environment and its negative effect on human health and the environment. This is one of the problems. On its own, it won't decay, and also it won't react with somebody. Okay, it's like a very rigid but more harmful. So that way, it was a very important element or harmful element in the uh, flow. So mercury now is even more important because UNEP globally legal binding treaty. The mercury is officially launched, and many countries have realized that, and they want to become a signatory. Almost around 170 countries have signed this agreement and to reduce the use of mercury in their country. And if you look at the history side, so starting from the king of first emperor of China, who has also been killed due to mercury contamination, and the second two biggest mercury poisonings. The first one is what is called Mad Hatter during the Industrial Revolution. The it's a very simple hat makers used mercury nitrate used as a lining in hats. And these toxic affected the brains because many people used their hat and they become a mentally unstable person. So that was the first problem with mercury. The second one, which is much more disastrous, is in Japan, 1952. A chemical company dumped mercury into Minamata harbor, and residents of local fishing villages contaminated, and a lot of people are died. So this is what is called the Minamata disaster. And afterwards, whatever the treaty, it is named after this Minamata. So that's called a Minamata Convention or Minamata Treaty. In 1971, the Iraq grain disaster. Many of the grains which were grown in some of the places in Iraq becomes mercury contaminated, and those people who are eating that grains had a problem of affecting. It mainly affects three things. One is kidney, another is brain, and third one is nervous system. Which are the three are important things for any person. So it's not only for human but also for the animals if they are taking it. And in 1997, which is the latest one, even the Dartmouth professor had a problem with mercury contamination. So even though it was historically found in Egyptian tombs, 1500 BC, Egyptian used as a cosmetics, causing some facial deformation and so on. And Greeks have used as an ointment, and Chinese have used this as a prolonged life and good health. And even in India, people are using mercury as in a lot of things in medicine, Ayurveda medicine, and it's mainly for prolonged life and medicine for many diseases. So that way, this mercury is in our life for a long time. So the Minamata Convention, what I have mentioned earlier, so our country also has signed like this. There are many countries have signed, and we have to first task is to estimate what is the emission of this mercury in the air, water, and land. So we have worked out a national project along with other IITs, and we have taken up with IIT Madras as a coordinating with IIT Roorkee, IIT Bombay, IIT Kanpur, IIT Delhi, and at the three sector on waste sector, air sector, and also process and product. So we have made a very good attempt to make an assessment of this mercury profile and also develop a capacity building for convention implementation. So now we are writing a project. Mostly we may get this project asset. And that's a very good contribution by all IITs for mercury profile for India. So this we have done a very detailed analysis. There are guidelines from UNEP. So we have done that. And this is overall balance what we have said. So even 2016, the total amount of mercury, what we are getting it as um, a tons per year. So mercury available for production is around 219.764. Used for making indigenous product is 173.58. Unusable, used available HC in the market is 44. So the total release from India, if you look at it, it's almost around 400 tons per year. So it is really very high. So we have to now come out with reduction of this particular one. So this is one of the things where ministry has really appreciated a good work we have carried out on that. And this is also not stopped here. So the perils of eating too much of fish, and the fish is having a very great capability. Whatever the mercury goes to water, it takes it and gets bioaccumulation. So and whenever we see a very nice fish and which was very shining, so automatically there will be a lot of mercury inside. And many people who are part of fish, they eat a lot, and these are the two people who are very famous people got affected by mercury poison. One is Jeremy Piven, actor, and Richard Gelford. So he is a IMAX CEO, had a big problem with mercury thing. So mercury is not a very simple element. So in fact, if you look at it, it's not only in land. And this mercury, whenever there is a chance, it will start moving either up or to the side. So mostly you will be getting around the global soil itself around 70,000 tons of mercury, and it goes into the thing together from air deposition and so on. It's around 330,000 tons. So you can imagine that it is every sector it is. So it is from land to ocean, and from ocean to again evaporated, and again come to river, and river to deep ocean. So it is like a grasshopper effect that the mercury is moving from one plane. Why we are more interested on this? So the wild card of climate change. So this will make increasing soil respiration due to warmer temperature, and this climate change may be as important as emission control to the future of environmental mercury century ahead. So this is one way if we can reduce the mercury, the emission also will be reduced quite a lot. So if you look at the overall cycle, so the maximum that it goes into is ocean. And also on the anthropogenic is only 2, whereas the overall land pollution, mercury is around 4, and the net mercury oxide, what it goes up is also 2, and the other side is. So totally in every country, it is around 200 to 300 tons per year that it is being consumed or somewhere it is used. So this need to be brought down to a greater extent. That is a treaty what it says. So let us just see something about the mercury in the environment. So once liberated from the actual rock crust, mercury can be mobile in the environment. So it is very difficult to control it. Enters environment through releases to air, water, and land, and it changes its form. And in fact, the elemental mercury is not that much harmful. Whereas when it starts converted into methyl mercury or other mercury forms, they are much more dangerous or even carcinogenic. So most human and animal exposure itself from eating contaminated fish. So this we may not be able to tell because fish can go take up to even around 200 grams or 300 grams that it can contain the mercury. And if you take that mercury, it is not by heating, it won't go out. It will be still there and you will be. So the fish accumulate mercury in protein and the primary source is from the air emission, it comes down to the water. And this all these products, okay, whether it is a bulb or maybe pharmaceutical or pesticide or maybe uh, beauty products, all those things contain some form of mercury or not. So that way, even the blasting side or paint, it will be containing some form of mercury, and even the dental amalgams, batteries. So battery has now they have divide of it, but still there are many countries the battery is containing mercury. So in the earth crust or in the rock, it is only 0.05 milligram per kg what it is there. The pure form is elemental or metallic mercury, what we call. It cannot be broken on its own or degraded. That's a very important phenomena. So on its own, it never degrades it. It may move from one place. Many forms, a few significant in the environment, mercury is highly persistent. Even around 1,500 years, the mercury reduction in a particular area will be less than 1%. Okay, so you can imagine the rate at which that it is. That's why it's called highly persistent. It will therefore be permanently recycled in the physical, chemical, and biological process in the environment. So highly toxic to both man and biota, except fish. Many mercuric salts are soluble in water. Mercury is not soluble. Mercury can also be transported by biochemical and biological reaction. So, in fact, that is the only point. So, not by chemical reaction, but mostly it is biochemical and biological reaction only will make it, but it will make it as more toxic. That was the major tragedy of this with the mercury. So that's example methyl mercury acid. So there are four forms of mercury in the environment. One is on the mercury sulfide. This is a normal occurrence. I am showing on the side. This is what is called cinnabar. And this then elemental mercury, then ionic or oxidized mercury and methyl mercury. Out of that, these two are little more careful. We should be careful, and especially methyl mercury, one has to be very careful. So the cinnabar is concentrated in a few deposits around the world, mined and refined to elemental mercury, and related forms found in many geological material, but very, very less quantity. On the other hand, the elemental mercury, it's a silver color, which we have seen in all our lab, everything. Main form in the atmosphere, most pollution sources, chemically inert, not water soluble, stays in atmosphere for up to 1 to 2 years. So if you release it into the atmosphere by any reaction, it will be staying there for 1 to 2 years before it comes to either land or to ocean. It's eventually oxidized to form ionic mercury washed up to the atmosphere. On the other hand, ionic or oxidized mercury very reactive and water soluble. Direct emissions are formed in atmosphere, get fixed to particles, washed out in the rain. Main form of mercury in soil, water, and sediment, and it is bioavailable. The form which can be easily converted to methyl mercury. And whereas methyl mercury is the most important thing, primary concern in environment made by aquatic bacteria in low oxygen places. That's the main problem. So it comes to there, the bacteria react with mercury and make it as a methyl mercury. And it's a neurotoxin to animals that eat fish, and wetlands, estuaries, sediments are the key production area. And people may ask what may be the uh, toxic effect on human. So in fact, the mercury affects every part of your body. So methyl mercury from fish consumption or breathing vaporous mercury. Uh, Methyl mercury affects central nervous system and irreversible brain damage. And it's a highly dangerous metal, corrosive, causes burn to skin and may be fatal if swallowed or inhaled, and harmfully absorbed through skin and affects the kidneys and central nervous system. And more importantly, it also affects the brain very much because the nervous system is controlled by brain. And this is what I have said as a mercury methylation, where methyl mercury formed by geochemical cycle. So this is, I don't want to go into detail. So anything what it comes in because of all these flora fauna which are there or benthic organisms, which will convert that into a methyl mercury acid. And the path is from the source, it comes either air, liquid or solid, goes to atmosphere or receiving water or land surface, and it comes back to aquatic food chain, which again comes back to people. So it may come to the human stomach and then affects the brain, skin, lungs and human. So this portion is where the methylation takes place as it. So as long as that it is in land, it may not be that much problem. So or it may be going into atmosphere, but atmosphere it cannot remain same. So finally it ends up in the aquatic food chain. So even you can just see the mercury biomagnification. So if it is 1 unit that it comes, so it can come to the almost around uh, 6 million times that it is biomagnification that it can take place. So we have the legal limit of maximum as 0.5 milligram per kg, but this is for the food health ministry. And these heavy metals are, this is one of the heavy metals, so which maybe it is not because of the lithogenic resources are there, but that it is very less by weathering the parent rocks, especially mercury. On the other hand, by industrialization, urbanization, and agricultural input, fertilizer, and so on, we get a lot of heavy metals, and mercury is one of them, and the soil is getting polluted. So now, what I am going to talk about is the soil pollution by mercury, what it will be, the system, how do we remediate the same. So the heavy metal in soil, it comes from various things, waste incinerator, industrial wastewater, or gasoline paints, pesticide, disposal of hazardous waste, or spillage of petrochemical. And this is one of the problem, disposal of hazardous waste into the land. It's a major problem in India, not only in India, but many developing countries. And even in developed countries during the World War, they have done this and that created a problems as such. So that leads to degradation of soil quality, decrease of crop yield, and quality reduction of agriculture and so on. So this heavy metal and especially mercury is having a big greater effect on the soil quality asset. So as a geoenvironmental engineer, we should be more worried about this heavy metal pollution, especially mercury acid. So the heavy metal contamination on industrial soil, okay, wherever the industry area is there. So mostly the harmful metals that it comes like zinc, lead, mercury, and manganese and iron that it comes from here. And whereas urban soil, it is more lead from petroleum and cadmium and copper will come in urban soil. So in fact, we have done a small study about between these two soil, how the pollution that it has come. So I just want. So before we go to the case study, let me just look at the contaminated sites, different part of the site. The major problem of contaminated site is the hazardous waste have been just dumped without any good containment, and which we are all now doing it. But earlier it was there that creates a problem even now because it takes a lot of time to get it clear. Most of the contaminated sites were created when there was no regulation of hazardous waste management rule, and the polluter responsible for contamination have been either closed down their operation or they just say we are not able to do, then the government has to do that thing. The existing regulatory framework does not outline specific rules for defining identification, fixing of liability, and this is one of the problems with developing countries. So that's why the company says, okay, we are not going to operate, it is for you to do that. But that's one of the major issues of contaminated sites. So the government is now putting a lot of money on the remediate all these contaminated sites. So, and 70% of the contaminated sites are concentrated in Europe and North America, and and also the mercury amalgamation and use of mercury in various product and process are dominant in mostly Asia, Africa, and Latin America. And so the contaminated sites in industrial or non-industrial areas are also there in many places. In Asia, particularly India, the number of mercury contaminated sites is growing. Okay, so where it is known, but still people have not done the analysis of the mercury all over the product. So the heavily contaminated mercury site, what we will be seeing it later. So these are all the areas where globally it is completely contaminated by different things. And also the mercury contaminated. So you can just see California is most affected area, and also the South America, and here also the and mercury contaminated. We have only two places. It was not put down here because the data was not available. So whereas there are all over mercury contamination also is there. Of course, there are other silver, gold, and other contamination. And the mercury contaminated sites in California is one of the very important thing, and also Australia. This they call it as a environmental time bomb. So these release significant quantities of mercury to the atmosphere and hydrosphere, where it is subject to mutilation, and it becomes a food web magnification or bioaccumulation. So especially modern artisanal small scale gold mining, and that becomes a problem. But luckily, we don't have a lot of gold mining, but mercury is having address in a lot of places in India. So we have in India, there are totally 321 contaminated sites, and they are all probable sites, and contaminated already qualified is 126. And the mercury contaminated sites, which are heavily contaminated, only have been found only two places, and there are probable sites out of 195. Definitely, there will be around 30 sites which are there. So this is distribution at a different state, and West Bengal is one of the highest contaminated site, and Odisha also is the contaminated site. It is there. So and the probable contaminated sites. So you have Delhi also. There are a lot of probable contaminated sites. So now this remediation, how do we go about it? So what are the ways that has to really look at it? So this is really mercury. It is very complicated. So it is not going to be staying there. It will be moving. It also get attached with the sediment quite a lot, and also on the surface and groundwater that it will be contaminated. And it's a time consuming. It is not possible to remove like even lead. You can remove it, but mercury it is very difficult to remove it, and costly effort. If you want to achieve zero mercury, it is not at all possible. So we do a primary assessment, site investigation, and there are many methods. We have to find out which method will be useful, and the final decision on which way that we have to go for the remedies. So I am going to take you through a case study of mercury contaminated site and how it has been done with a risk assessment approach. So we also, as IIT, we have involved as an expert advisory committee, and also we have done some work on this particular thing on two aspects. NERI has involved. So I also, thanks to them, they have permitted me to use their results for this presentation. And also ERM, and there are many Indian Institute of Toxicology also has studied this. So I'm going to take you through how it has been done, and still the problem is not over. Okay. So Mercury was released because nobody knows about it. So a company started at 1984. It is in Kodaikanal. So Kodaikanal is a place like Darjeeling, where it is very cool, and it's a hill station at an elevation of around 2,200 meter, and it's a very ecologically fragile area and very good favorite climate condition. So mainly they have chosen at that time because the mercury vaporization should not happen. So this is a place where the mercury may not vaporize, but unfortunately they have made a mistake of dumping the waste into the land. Occupies an area of approximately 87,000 square meter. The manufacturing area had 36 exhaust fan to facilitate air exchange to maintain the workplace, but it was not at all sufficient. Standards to 0.05 at that time. The expelled air containing mercury vapors from the manufacturing area settled down on the surrounding soil as well as on trees. So, in fact, when we have checked up the trees, there is a lot of mercury contamination. So, it cannot grow as a healthy tree without this mercury contamination. Close to the manufacturing area, the production was around 20 million per annum. It is more thermometer, clinical thermometer, and it was mainly set up by Bond's original company in 1983. Then it was sold to Hindustan Unilever Limited from September 1998. So, in fact, disposal of mercury containing glass scrap to a scrap dealer in breach of the company's procedure was brought to the notice by NGOs on 7th March 2001. So 7th March 2001 only, this was before that they have done a small study and find out the mercury level in the lake as well as on the soil and the entire area, many areas, there is level is very high. So the NGO was, there is one Jayaraman who has really made a very good study about this and then brought out this particular one. Almost around 130 employees were, because the company was immediately closed, and they have been provided alternate employment with the same company at other places. But many people could not go to Gujarat and other places. Say they took the voluntary retirement, but they are still being affected by mercury contamination. At that time, they were not knowing about the problems with mercury. So the site, it is more on the whole site is underlined by a shallow, impermeable bedrock, mainly granite and sarconite. The soil profile is very thin, but it varies from 30 centimeter to 20 centimeter to 60 centimeter, and some places it goes up to 2 meter. Otherwise, it is more, but these sandy soil have lot of trees which were there in this particular area. So this is a site, and in fact, there were around 40 samples which have been collected in this area. All of them have mercury, which was maybe 10 times higher than the, not 10 times, it is 40 times, 50 times, so on. So you can just see these are all the samples the NERI has collected, and we have also collected some samples and tested these different areas. Because this we have done, we will come back to later on risk assessment. We found the risk assessment on the outside or the risk due to mercury was not that much, but inside the thing, if you don't take any action, then it may go down to the lake and other places. That's why we thought that this is a major area where we have to contain the mercury. So the studies were conducted by James Moore, ERM and NERI, and remedial action undertaken by EIA and RA studies. Soil from 3 areas within the factory required remediation, and we were in the special advisory committee or special expert committee or scientific expert committee. Considering the contamination of soil and biomass in the factory premises and harmful effects of mercury through various exposure pathways, the present study was undertaken to develop a risk-based remediation approach for the mercury contaminated areas. So this procedure is as per EPA, USA, but we have analyzed the risk assessment over this. So you can just see now after 2001 it is not being operated. So you can just see this is a bakery area where glass scrap was stored. And you can imagine the whoever has taken the bakery products, they would have a lot of mercury. The south of Ponds Path, east of Stream, close to mercury recovery room. And this is south of factory, and this is a manufacturing set. And this is where again the recovery rooms. So what we have found, the mercury distribution in that particular area. So you can just see the volume of greater than 500 milligram per kg. So this is high, and 25 meters square area it is there. That means it is full of mercury. Out of 1 kg, it is more than half kg is mercury. Okay, and volume is 8 and weight is 14. 100 to 500, it is 1230 and 369. So, of course, we multiply that. And 50 to 100 and 10 to 30, it is 7480. And volume is this much and the weight is this. So, one is this much mercury is there, but we were not interested in looking at this mercury recovery, but at least can be remedied by so that the people are not contaminated with mercury. So if you look at it, the reactive and non-reactive, which were going into the water column. So we found that this is what it is, the reactive mercury, how much it is there, and the non-reactive mercury, and contribution of pore water to enrichment of the water column is how, in fact, it is more for non-reactive, but rather than reactive, but it is quite a lot amount that it is going. So, in fact, the mercury level in the outside, okay, the groundwater samples collected across the site contain mercury concentration below laboratory detection level of 0.003 milligram per liter. The concentration of mercury in the sediments was less than 0.2 milligram. This is outside. So, since the concentration of elemental mercury in groundwater samples and sediments are insignificant, no remediation are required on the outside. And mercury level in the park and lichens of 3,000 trees within the premises, what it has been found. So it was high concentration of mercury, 1.24 to 87 milligram per kg. Since a plant is shut and the sources are eliminated, the accumulated concentration of mercury in the trees, especially bark and lichen, will continue to come down due to growth and decay. Hence, no remediation is required. So these are all. At that time, I used to say we compromise ourselves, but this also may come down and then go down. So this is what we were telling, but there are a lot of arguments and so on. But still, it is really a very big place of contamination. So the offsite mercury distribution, it is somewhat less, and as per the US EPA guidelines of 6.1 milligram per kg in the residential area. So this almost in lichen, it goes up to 6 to 9, but we compromise that it is not needed. And if I have to do the remediation, it will be really very, very next to impossible. So this is also on the lake, what we have just near to the lake, boundary of the lake. So you can just see the total mercury, okay, multiplied by 100. So you can just see how it is. And methyl mercury. So methyl mercury, what I said, it was very harmful. So you can just, it is, as you go into the depth, the lake, the methyl mercury is very high. That means it is already reacted and it is getting into the sediment. Okay, so that means there is something that both geochemical and also the environmental side, we may have to study quite a lot. That means all the places it is proved that the methyl mercury, sediment, and pore water, everything is more than the limit. Hello. We have had a discussion. So the first thing what we have said is remedial action one, retrieve the scrap material which were put out inside in a safe way and has to be brought back because they have sold it to some people and they have put on at a different point. So that all those things have been collected from that. So it is almost we have, especially on musical scrapyard, is where the lot of storage were there that has been taken. The second is construction of filter trap, so that even the mercury what it comes from the soil should be trapped inside. So it has been constructed these kind of barriers, or this is one filter trap, so the water may go, but mercury will be staying there. So, and also this is another kind of a trap, and this is also if this is a place, then it has been marked with this particular one. And it's also necessary to safeguard the trees. So 1:10, the native plant species that have been planted, and there are mainly wherever the excavation is done, the tent is erected and so on. This is the remedial action 2. So remedial action 3, what it has been done is export the mercury bearing material to recycler, because there was no recycler in India. And so there is a lot of money we had to spend. So the government had spent a lot of money. Of course, the company also had spent money. So it was shipped through the port from Tuticorin to Bethlehem apparatus, USA, and they are the recycler for mercury. So one complete ship was gone to USA. Okay, so this may be the first instance where the hazardous waste movement from India to USA. So this many of you may not be knowing, but it has gone there. And the last, or this is one of the thing is remedial action 4. It's a decontamination and disposal of the machinery, everything. So this supervised by the expert committee where IIT create scrap dispatched to USA, need to remediate the contaminated site where mercury waste have been stored. So what are the methods that we can do on site remediation? So this one, what we have done it is a risk-based remediation, a 3-tiered process using a conceptual site model to determine site-specific target level. So there is no standard thing, but if the site-specific target level is achieved, we assume that it won't further flow down, or it won't get into another area and create a problem. So this was a very, it went to court and it was challenged quite a lot. And we have started with a higher SSTL, but then finally we agreed upon certain or lower SSTL. Then finally we agreed upon one value. So that was done by a risk-based remediation, which ERM was the consultant who has done it. The risk assessment study considered the linkage between source, pathways, and receptor. In this model, a 3-tier probabilistic approach using realistic scenarios was considered, and the toxic issues were identified, hazards and exposures were assessed, and associated risks were characterized. So we have done 3 tiers, what I said. The first tier is comparison of observed chemical concentration with conservative generic screening criteria. Then evaluation of risk from the contaminant concentration observed. Then probabilistic approach using realistic scenario. So here, the site-specific target level using a conservative tier 2 and tier 3 probabilistic model on future residential use of the site, what we have done. And here we have considered the receptor as a not a grown human being, but a child with 6 years. What will be the contamination that it may be creating? So this was a flow chart. Because of the time, I'm not going, but it has been very well done a good job. So identification of the nature and extent of concentrations of substances in different matrices of the contaminated site and of the site condition, even the blood concentration of mercury also have been taken, whoever has worked there. Results provide key information for risk assessment. The risk based can be derived based on quantitative or qualitative human health risks caused by particular constituents, and these levels have been decided for each site separately, adopting either the risk-based approach or standard-based approach. Mostly the risk-based approach what we have used. So what is this risk-based approach? So what we have done it is, what is the maximum allowable risk level? And then we try to calculate what is called hazard coefficient. So this is as per our EPA. So currently also we are doing something on emerging contaminant. One of our scholar is doing on that. Is considered all pathways, assuming that the 1 milligram per kg of soil that is there, how the hazard coefficient will be by all the pathways, air, water, and fish, and their eating habits or vegetable, and or thermal contact or dust inhalation, indoor, outdoor, all those things based on which we have calculated what may be the threshold SSTL for which they can tolerate. So this is over the lot of work has been done, and this is what the values what we have got. This is the residents, the soil ingestion in case where the soil is there, and because of that it is inhaling what it goes up and so on, and dermal contact and indoor dust inhalation, outdoor dust inhalation, vegetable ingestion, including fish. So it is also that has been taken into consider. So we have calculated the hazard coefficient, which is 4.02 into e power minus 02, which is equal to 0.04. Whereas the recreational people, there are a lot of people visiting there. So for them, the dust inhalation indoor and vegetable ingestion is not there. So that's why we have not taken that into consideration. It is 0.035, slightly only it is less. So we have calculated both the risk coefficient, and for child residents, it is 25 milligram per kg is the SSTL, site specific. You can just say the target level. So that means 25 milligram per liter. This is what the risk assessment what we have calculated. For child recreational users, it is 29 milligram per liter. That means if it is lesser than 25 milligram per kg, if we can remediate the soil where it is more than 500 milligram per kg, then we are on the safer side. It is not completely safe, but it is on the safer side. So what we have got 25 for residential and recreational user. So these 25, I think the NGOs did not agree upon it. The NGOs were go on saying that it should be adopt that 0.05 milligram per kg. So that is what they wanted as it. But this is a well-proven method. The court has finally given verdict that this method is correct. So instead of 25, finally the court has fixed upon our recommendation as 20 milligram per kg. So if the soil contamination of mercury can be less than 20, okay, and some places it can go for 25. So that is what we have, where it is not residents are not used. So it can go for 25, but maximum 25 milligram per kg. That is one of the very nice exercise that has been done. So SSTL finally, after detailed discussion with the Pollution Control Authority and the expert, it was finally decided that site-specific target level is fixed at 20 milligram per kg. So now, based on that, we really estimate what may be the magnitude of the remediation. So it was estimated that out of 7,358 million metric ton of mercury contaminated. So, and almost around 3,881 metric ton is in the range of 10 to 25. So that means remaining things have to be corrected. Considering the fragile ecosystem of the area, it is not advisable to remediate areas having less than 25. And a total quantum of soil that would require a remediation is minus of this. That means about 3,500 metric ton that you have to remediate. Based on the detailed review of risk assessment study, the SSTL is recommended for other program, but 20 is what it is finally pitched upon. So now there was what method that we have to use for soil remediation. There are many methods. So whether you remove all those things and go to secure landfilling. But at that time, we don't have a good secure landfill. Secure landfill came a little later, 2007 and so on. So this is rolled out because if it has to be transported, it has to be transported somewhere else, not within the state. Or the state was not ready, they have to store up to around 2000. In fact, the nearby site was ready by only 2009. So, and the second option is vacuum distillation or thermal retard, soil washing, and there are other methods, solidification, containment and capping, phytoremediation. But these are all takes a lot of time. And soil flushing, finally, where it is going. So it was leaching out and so on. So finally, what we have after a detailed review of available technologies, their applicability under the present site condition, and considering the 20 milligram per kg, what it was finally decided is only
So, Professor Mohan, we can't hear you. You have to reshare the presentation. And yeah. So you please unmute Professor Mohan. Yeah.
okay.
Yeah.
Yes.
Good.
So what we wanted is we try to do a soil or laboratory study. So one of our person from Police Control Board, he has done the work in IIT Madras at that time. He is now the chief engineer in Madurai. So find out in soil washing along with some chemical, because soil washing alone may not be helping a lot. So we have done a detailed analysis, chemical enhanced soil washing. Okay, and then retard was tested with a bench scale reactor, which was this was done by the company itself. So they have done this particular system. So let me just go to and just quickly, the areas delineated is ABC, and some places it is only thermal resort, some places combination, some places only washing or washing plus chemical. So the contamination level are different. That's why we have divided into 3 areas, and almost around 500 trees in the contaminated areas, and 5 buildings are also have been decontaminated and demolished. And those demolition waste also contain a lot of mercury. That was a very important thing. One of the problem with this site is it's a highly sloping. So even if you are putting at one place, it goes down all the way to, and they produce a lot of lettuce, carrot, and those things which are very demanding from the people. So, and this is you can just see where the mercury concentration is less than 20 ppm, only less place, and these are all more than 100 ppm or even 5, and this is 20 to 100 ppm. So these places may not be needed because less than 20, whereas other places that it is needed. So, and what we have done it is soil washing. So polluted soil, you have a scrubbing unit and clean it with the water and detergent. And also we have used a chemical washing. So we have done many different chemical we have tried and come out with a chemical which I will just only tell the results. And soil washing project which has been done in other countries also have been reviewed. And so mainly to reduce the truck movement and so on. So these are all the case studies what we have considered before we decide upon the soil washing plus thermal retard. So this is not a unique in Spain, UK, and Canada, and USA, New Jersey, and also USA, two places that they have remediated the site. So some places it's hydrocarbon with the mercury. So what we have finally come out with the soil remediation, as I said, it is the treated soil after this particular one, which were again backfilled on the at the site and then protected. And uh, and you can just see this is how the results were at different. We have at 5 washings. So you can just see in some places where if it is 20 to 30 or up to these, there is no problem. It will come back to less than 25 or whatever it is. Whereas in some places, this is alone is not sufficient. So we have to go for a vaporization or thermal retard. So these areas we have used soil washing, dried up, and also thermal retard. Uh, and this is a pilot plant on soil washing feasibility studies. And this is a soil washing plant, then vacuum resort or thermal resort, and then it comes for even the processed water. 5 times the water has to be treated and homogenizer, and then the treated soil that is okay. And whatever during this period, the evaporation also will be handled by a air emission control system. So, and this is a big plant which has been erected there as a soil washing plant. So, just to tell you, this is how the final thing what it has come. So, washed soil above 25 mm and 5 to 25 mm and 1.5 to 5 mm and washed soil less than 70. And in fact, this was the most difficult one. So whereas this, the soil washing alone will be enough. Where the soil is around less than 1.5 mm or up to 75 micron, it was not leaving from that. So then we have to go for a chemical washing and thermal retard. So what we have done it is that's why the mercury vacuum retard plus in fact it's a computer operated retard, and we have and then it will be vaporizing and cooling it so that the mercury is separated and soil is separated. It's like your zero liquid discharge multiple effective operator kind of thing. But you can imagine uh, evaporate the mercury, it takes 1200 degrees C. Up to that it needs. So this is a combined system where we have also carried out. And this is, in fact, washing of the washed water, soil washing water. That itself is a treatment plant which we have done with carbon treated slide folding, and this is where our environmental engineering, and we made all the filter, then it came out little better. The water is also. Uh, so the soil washing, but we have gone for chemical enhanced soil washing. It's more on it is not only physical separation, but chemical extraction also that it is done. So one of our student Manoharan has done, it's a physical separation. That is what soil washing, clean soil fraction, contaminated soil fraction. And whereas on the chemical side, it is chemical extraction, processed and clean soil, and both physical separation and chemical extraction. So this is what we have adapted, or especially on the less than 1.5 mm size soil. And this is how the washer and trommel, which will be rotating. And we have 4 or 5 times that the washing were done. And finally, the clean product, especially less than 2 mm, we have used this thing. And in that, the idea is we have used only water. So you can just see the removal efficiency is only around 15%. That means you may have to wash it many, many times if I want to bring back to 20 milligram per liter. You can imagine 500 milligram per kg. If I have to bring it to 20 milligram per kg, and if it is only 15% efficiency, how many times that you have to wash, you can find out. Please remember, it is not only the number of times, that much water you have to treat it. So that was also a problem. So what our engineer has done it is, so we come out with 3 chemical wash which is not harmful to the environment. So Na2EDTA, KCl, and potassium iodide, potassium chloride, potassium iodide, which is not harmful in, for the environment. So what we have done, you can just see that by adding 1% of Ki, so we are able to reduce or increase efficiency by 80% or 84% or sometimes 88%. That was one of the very good finding by our student. So who did his masters with us, and you can just see the pH. So it is not only the solution but also on the pH. So this is effect of pH on, this is a washed soil. What is a mercury? So you can just see 8, the washed soil is around 60. So if I want to achieve the 20 milligram per kg, I have to go for a pH of 2. So pH of 2 and 1 mole solution of Ki, and the third point is the ratio of solid to liquid. So that also makes a thing. So we found 1 is to 12.5. Okay, so that means the solid and the liquid. You can imagine if I am washing 1 kg of soil, 12.5 kg of water that I have to use. Okay, so and with all these things only, so you can imagine. Luckily, there are water, but it has to be. It was really a Herculean task. And the K concentration, again, we have done different molar. We found that 0.1 molar. That's one of the good things, that it is very 0.1 molar itself. It gives a very good solution. So that is one of the chemically enhanced soil washing. That is what we could get. So we got around 88% of thing between at solid liquid ratio of 1 is to 15 at pH equal to 2. So that is one of the good result what we have got. And so this is again here the emission control, whatever it is done, it was done almost like a closed chamber, and the mercury vapor was getting extracted and then try to be used or remediated. And this is also we have done the air monitoring so that there is no excess of air with the mercury that it goes out. Afterwards, it is this was well proven, but it has been started working on it, and they have completed only last year. So you can imagine, 2001 they have started, and 2020 only they have completed, and now the Pollution Control Board has given permission for them to go ahead with the job or with the factory, but they are little hesitant because they don't want another problem here. But still, the problem is not completely solved. Okay, so the problem is even recently, IIT Hyderabad has checked up the water quality in the Kodaikanal lake. They found that it is still higher than our own limit or EPA limit. Okay, and another dimension of it, the occupational health. So the people who are all employed invariably started from the MD up to the lowermost worker, there was a lot of contamination. That was one of the pity of this particular company. So that's what they were saying that it is going to be. And the government also made a decision to dispense with mercury thermometer. So maybe another within 2 years, the mercury thermometer will be completely out from. It's more on digital thermometer that we have to. Even though there were a lot of opposition in the workshop what we had, but I think government was very clear on it. And this is a lake, and in which they have measured that it was found that it is slightly above that. So automatically, what will happen if the mercury level in the lake is higher, the fish also is going to be higher. Luckily, people are not eating the fish. Maybe we don't know because there are so many hotels are there. They may be taking the fish from here in the night. We don't understand it. So this is one of the major issues, and so the ambient level of mercury even immediately found outside the factory premises, and the Kodai sediment zone, it is even the other places which are other lake. So even there are two lakes which are around 50 kilometers from this particular area. So that also shows around 276 to 350 milligram per kg of the total mercury, and in that at least around 30% will be methyl mercury, so about 6% of methyl mercury. So you can see that that itself is getting affected. That means the mercury get vaporized, sifted by air, and get deposited in the nearby lake. So those who are very near to Kodaikanal, even up to Vaigai Dam, or which is around 50 to 60 kilometers, they found that mercury is contamination is methyl mercury is high. That is what they have listed out. So what we have, I'll just take another 5 minutes with the permission. So what we have done is, what is the way that how this groundwater and soil contamination affected that area. So we have taken the samples, and these are the samples what we have collected, and we have modeled it with a groundwater model, with reactive model, what we have done. So, and I'm not going into detail about this thing. So we have done georeferencing properties. This is a very simple layer, recharge value. In fact, the recharge is very high here, and boundary conditions running the model. So what we wanted to say, so 30 to 60 centimeter depth, and this is a grid size, and the background you can see the site. So this is what we have models and observation belts on the boundary, and head boundaries what we have given. So we calibrated from 2001 up to 2020. It's not 2002, 2020, and after calibration we try to do the validation for 1 year and then predict for later. So what we have found is, this is the modeling side, and what is the way that this will be moving, which direction. So most of them, if you look at it from this is a side, luckily this is little above the side, and the groundwater is started moving on the other direction. On the other hand, if the Kodaikanal lake is on, but even there, it is not groundwater polluted, but mostly the air, mercury, through air, it goes and get deposited. That itself is very high. So whereas the groundwater is very much higher potential that it is there. So what we have, this is contaminated. So how the contamination will be moving over the period. So this is in 2001, then they have 84 onwards, then they have put on that, so 2001 or 90. So this is what in 2001. So these are the two risk area what we have identified, and in this is 2015 and 2021. It is getting disseminated, but contaminated area is there, and this is we have the contour level of mercury concentration. And what it has happened over the years that it is getting reduced does not mean that not like other chemical or other heavy metals which can react with something. But here it is only getting dispersed either through air or through water. Mostly it gets vaporized through air during the higher temperature period. So it comes down, but it is not beyond the mark. So my conclusions are the operation of mercury in glass thermofactor located is really extensive contamination of soil and biomass. So many times that we never check the biomass, but here is a case where biomass also needs to be checked. The total volume of mercury contaminated soil was 7,358 metric ton, and with a cutoff of 10 milligram per. Okay. And if you consider the site-specific target level of 25 for a child resident, so at least around 3,500 tons of soil required remediation. So they have completed now, and we found the technology, which is a combination of soil washing and thermal retarding and soil washing with chemical enhancement. So that is one of the take-home message for you. And the lab-scale studies for soil washing and with chemical enhancement and thermal retarding, and it's a very high feasibility. And comparison of mercury concentration has been decreasing over the time, possibly due to the remedial action as well as contaminant movement. And comparison of all the year, the mercury concentration range 2001 has come down to 0.41 milligram per kg in some area of the thing that it has come because it is getting dispersed. Again, I am reminding all of you that it is not a reactive chemical or reactive heavy metal. It is very, very non-reactive, and it will be staying for more than 1 or 2 years, even in air. And based on the study, potassium iodide was a suitable washing solution to be applied in the absorption of mercury in the soil. The optimal condition of pH2 concentration is 0.25 molar and even 0.1, and a solid liquid of 1.15. So we could able to remove potassium iodide can remove mercury up to from 7.9 milligram per kg up to very less thing, whereas here also it is, and a non-mobile fraction of this. So these results demonstrated that potassium iodide was a very suitable to be applied for enhancing the absorption of mercury in the soil with a desorption rate of 0.0025 minutes. So potassium iodide vaporizes on its own. There is no need that you have to take care of it. So that way it will be really helpful. So thank you very much. I really acknowledge the opportunity provided by Professor Reddy and also DIRI and Pollution Control Board, Tamil Nadu Pollution Control Board, and HUL for providing the data for our study as well as for this presentation. Thank you very much. I hope that I much of your time.
Excellent, sir. Thank you so much for your presentation. You can stop sharing your presentation, and then you can go into the chat box, and you can go from the beginning and see, any questions that you want to answer. While you're doing that one, I just want to say that your presentation was excellent. I mean, I really wanted to see, case studies like what you presented, to identify the problem and try to resolve the problem. As many of you know, in US, we have a good idea about the number of contaminated sites, and there is a legal framework under which